This lesson, we're going to learn how to solve polynomial inequality algebraically. Step 1, we need to have a 0 on one side of the inequality sign. Step 2, we're going to fully factor the polynomial in order to find out the zeros in step 3. And step 4, we're going to use the zeros to cut the number line into different intervals and check the positive and negative sign. Step 5, then we're going to use our number line to determine which section satisfies the inequality. And we're going to use interval notation to write down our final answers. Example 1, when you have a linear function as an inequality, we could just isolate for x to find our answer. So in this question here, we could just subtract 5 on both sides, then we get x is greater than negative 5. So therefore, x is element of negative 5 up to positive infinity. Example 2, when you have a 3-interval inequalities, we are going to isolate for x. So we subtract 3 on every single interval first. Then we're going to have negative 10, last equals to 2x, last equals to 6. And we're going to divide it by 2 on every single interval to isolate for x. So we get negative 5, small equals to x, small equals to 3. Therefore, write as interval notation, we say x is element of square bracket on the negative 5, because including negative 5, all the way up to positive 3, round bracket, because there's no equal sign on the 3. Example 3, now we have a quadratic inequality. First, we have to subtract 42 on both sides to get a 0 on the right-hand side of the inequality. Step 2, we're going to fully factor the polynomial into x minus 7 times by x plus 6, last equal to 0. Step 3, we're going to find the zeros. X minus 7 equals to 0 means x equals to 7, or x plus 6 equals to 0 means x equals to negative 6. Now, we're going to put those two zeros on the number line to cut the number line into 3 different intervals to check the positive and negative sign. There are 2 ways to check the positive and negative sign. One is substitute the x value directly into the function to see it is positive or negative, or we could create a chart to help us to find the positive and negative sign. Method 1. We're going to do direct substitution by substituting the x value into the function to determine the positive and negative sign. For the most right-hand side interval, x is greater than 7. Let x equals to 10. Substitute into this function, 10 minus 7, positive. 10 plus 6, positive. Positive times by positive is going to be positive. Next one, between negative 6 and 7, let x equal to 0. 0 minus 7, negative. 0 plus 6, positive. Negative times by positive will be negative. Next one, x is less than negative 6. Let x equals to negative 10. Negative 10 minus 7, negative. Negative 10 plus 6, negative. Negative times by negative will become positive. Method 2, let's use the chart to find the positive and negative sign. So for the first factor, x minus 7, we know if x is greater than 7, the value inside the bracket will be positive. If x is less than 7, the value inside the first bracket will be negative. Next factor, x plus 6, we know if x value is bigger than negative 6, the value inside the bracket will be positive. And if it's less than negative 6, the value inside the bracket will be negative. And now we're going to multiply them together. Positive times by positive is going to be positive. Negative times by positive is going to be negative. Negative times by negative is going to be positive. Now, we have the same positive negative sign on the line as the first one. After we have the positive negative sign on each interval, then we have to go back to our inequality to see which interval will be the solution. And as you can see, we want our function to be smaller equals to 0. That means we are looking for the intervals that have a negative sign, which is here. So we know this is our solution from negative 6 to 7. At the same time, we need to make sure whether or not we need to include the zeros, because there's an equal sign on the inequality. That means we do want to include the zeros. So our solution will be from negative 6, solid dot, all the way to 7 with a solid dot. So let's make a conclusion. Therefore, x is element of square bracket, negative 6, comma, 7, square bracket. Example 4, the first thing is to add a 49 on both sides of the inequality. So we have a 0 on one side. Next, we're going to factor out a negative 1 to make the quadratic relation easier to factor. Then we're going to factor the quadratic relation into x plus 7 times by x minus 7. Then we're going to find out the zeros. X plus 7 equals to 0 means x equals to negative 7. Or x minus 7 equals to 0 means x equals to 7. Next, let's make a number line and put those two zeros on negative 7 and 7 to cut the number line into 3 different intervals. And now we're going to substitute the values into the function to check the positive negative sign. So the first number we're going to use is going to be 10, which is on the most right-hand side interval. So negative times by 10 plus 7 times by 10 minus 7 will be a negative. So I know the right-hand side interval will be negative. And in between negative 7 and 7, let x equal to 0. Then we have a negative times by a positive times by a negative is going to be a positive. Then the last interval, let x equals negative 10. We have a negative times by a negative times by another negative, which is going to be negative. Now that we have the positive and negative sign on each interval, we can go back to the inequality to check which interval is the solution. We want our function to be greater than 0. That means we want the interval that has a positive sign, which is in between negative 7 and 7. However, this time we don't have an equal sign on the inequality. That means we do not want to include the 0. That means we are going to have an empty dot on negative 7, all the way up to 7 with an empty dot. Therefore, our answer will be round bracket, negative 7 to 7, round bracket. Example 5. Now we have a cubic inequality, and we already have a 0 on the right-hand side of the inequality. We just need to factor it to find out the zeros. However, let's look at the coefficient. We see 1 and 3 for the first two, and the next two, they have a common factor of negative 4. And if we factor out negative 4, you'll get 1 and 3 again. That means this cubic function can be factored by grouping. So let's group them up. We group the first two terms and the next two terms. And look at the first group. They have x squared in common. And we factor out the x squared, so now we have x plus 3. And for the next group, they have negative 4 in common. We factor out the negative 4, now we have x plus 3 again. And look at those two terms, they have x plus 3 in common. So we factor out x plus 3, now we have x squared minus 4 in the second bracket. And this is a difference of squares, so we can factor down further into x plus 2 times by x minus 2, last equal to 0. Now, we can find the zeros. So x plus 3 equals to 0 means x equals negative 3. X plus 2 equals to 0 means x equals negative 2. Or x minus 2 equals to 0 means x equals to 2. Now, we are going to put those 3 zeros on the number line to cut the number line into 4 different intervals. Let's check the positive negative sign. So for the first interval, x greater than 2, let's choose 10 for x. So we substitute into the function 10 plus 3 positive, 10 plus 2 positive, 10 minus 2 positive. Positive times by positive times by positive will be positive. Now, the next interval between negative 2 and 2, we're going to choose 0, x equal to 0. 0 plus 3 positive, 0 plus 2 positive, 0 minus 2 will be negative. So 2 positive sign, 1 negative sign, the result will be negative. Next one. Let's choose x equals negative 2.5 because that's in between negative 3 and negative 2. So let's put negative 2.5 into the first bracket, will be positive. Negative 2.5 plus 2 will be negative. Negative 2.5 minus will be negative. Positive, negative, negative, the result will be positive. The last interval, let's choose x to be negative 10. So negative 10 plus 3, negative. Negative 10 plus 2, negative. Negative 10 minus 2, negative. 3 negative sign, the result is going to be negative. After we have the positive negative sign, let's look at our inequality again. We want our function to be smaller or equal to 0. That means we want our function to be negative. At the same time, we want to include all the zeros. So it will be this region here and this region. Therefore, our solution will be x is element of negative infinity, comma, negative 3, square bracket, union, square bracket, negative 2 to 2, square bracket. Example 6. Now we have a negative 1 as a leading coefficient. So the first thing we do is we factor out the negative 1. Then we let fx represent the round bracket there. And we're going to use factor theorem to factor them. So we try f at 1, we try f at negative 1. They both are not 0. Then we try f at 2, which is a 0. That means x minus 2 is a factor. After we find the factor, we use syntactic division to find the quotient. Then we can rewrite the inequality to be negative x minus 2 times by the quotient x squared plus 5x plus 6, last word equals to 0. And now we have to factor this quadratic trinomial down into two other brackets to be x plus 3 times by x plus 2. Once we have the factor form, then we can find the zeros. So x minus 2 equal to 0 means x could be 2. X plus 3 equal to 0 means x could be negative 3. X plus 2 equals to 0 means x could be negative 2. After we have the zeros, then we put it on the number line to cut the number line into 4 different intervals. Then we're going to substitute different x values from each interval into the function here to check the positive and negative sign. So for the first interval, we will use 10 and the result will be negative. The second interval, we are choosing x equals to 0. Put into this function, the result will be positive. And the next interval, we're going to use negative 2.5. Substitute this function, we will see a negative. And the last one we're going to use is going to be negative 10 from this interval. Put into this function, the result will be positive. Let's go back to see which interval will satisfy our inequality. So we know our function must be small or equal to 0. That means we are looking for a negative region, and we also want to include all the zeros. So first, we include all the zeros on the number line, and we want to highlight the region that are negative. Therefore, our solution will be from negative 3 to negative 2, union from 2 to positive infinity, and round bracket. Example 7. We already have a 0 on one side of the inequality, and the polynomial function has already been factored. So now we just need to determine the zeros. That x equal to 0 means x equal to 0. X minus 3 could be 0 means x could be 3. Or x plus 2 could be 0 means x could be negative 2. Or x minus 6 could be 0. That means x could be 6. Let's arrange those zeros from the smallest to highest and put them on the number line to cut the number line into 5 different intervals. Then, let's check the positive negative sign for each interval. For this interval, we let x equals to 10. That's substituting to the function, we get positive times by positive times by positive times by positive. So the outcome will be positive. For the next interval, between 3 and 6, let x to be 5. Substituting the function, we get positive times by positive times by positive times by negative. So the outcome will be negative. For the next interval, we let x equals to 1, which is in between 0 and 3. Substituting the function, we get positive times by negative times by positive times by negative. So we're going to have positive. Then we're going to choose x equals negative 1 for the next interval, and you will see the outcome will be negative. And we're going to choose x equals negative 10 on the last interval, and we will see the outcome will be positive. After we have all the intervals, let's go back to our inequality to see which interval satisfies the solution. So we want our function y to be smaller or equal to 0. That means first, we want to include all the roots because there's an equal sign, and we want to find the interval that are negative. So it's here and here. Therefore, our solution will be from negative 2 to 0, union from 3 to 6. Remember, we need to use square bracket for the roots because we want to include the roots as there is an equal sign on the inequality. Example 8. The only difference this inequality is different from example 7 is there is a negative sign in front of the x. So first, we find the zeros. We get 0, 3, -2, and 6. Again, we arrange them from the smallest to the highest and put it on the number line to cut the number line into 5 different intervals. Then we're going to check the positive and negative sign for each interval. Then we will find out it's going to be negative, positive, negative, positive, negative. And let's go back to the inequality to see what we want for the solution. We want our function to be smaller or equal to 0. Once again, since there is an equal sign, so we want to include all the zeros. Then we want our y value to be negative. That means we want to have all the negative intervals. So this time, our solution will be x is element of negative infinity using round bracket to -2 square bracket, union square bracket 0 to 3 square bracket, union square bracket 6 all the way up to positive infinity, and round bracket. Once again, for positive and negative infinity, we always need to use round brackets as we cannot determine what infinity's value is. Example number 9. Now we have exponents on the factors. So first thing we do is we find out the zeros. X minus 4 equal to 0 means x equals to 4. Or x plus 5 equals to 0 means x equals -5. Or 8 minus x equals to 0 means x equals to 8. Now we have 3 zeros. Put it on the number line from the smallest to the highest, -5, 4, and 8. We cut the number line into 4 different regions. Now, let's substitute different x values in from each interval to the function to find out the positive and negative sign. So in this region here, we're going to say x equals to 10. And that will be positive, positive, negative. So the answer will be negative. Next one, we choose x equals to 6 to substitute into this function to check the positive and negative sign. So that will be a positive, that will be a positive, that will be a positive. So the next interval will be positive. Next one, we let x equal to 0 to find out the positive and negative sign. So substitute into the function, that's positive, that's a positive, that's also a positive. So the outcome will be positive. The last interval, we're going to say x equals to -10. Substitute into the function, we get positive times by negative times by positive, so the outcome will be negative. Next, let's go back to our inequality to see what we want. We want our function to be greater than 0. That means we want positive region. And since there's no equal sign on the inequality, that means we do not want to include the zeros. So all the zeros will be empty dot, and we want to have the positive interval. So therefore, we say our x is element of round bracket -5 to 4, round bracket union, round bracket 4 to 8, and round bracket. Example number 10. Now, not only we have a exponent of 2, we also have an exponent of 3. So let's try this. First, find out the zeros. We get x equal to 0, or x equals to 3, or x equals -2, or x equals to 6. And put it on the number line. Cut the number line into 5 different intervals and arrange the zeros from the smallest to the highest on the number line. And now let's check the positive and negative interval. So we're going to use 10 for the most right-hand side interval. Substitute the function, we get positive, 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 positive. The outcome will be positive. Next, we're going to choose 4 as our x value. Put it into the function here. We get positive, 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 and negative. So the outcome will be negative. Next one, I'm going to choose x equals to 1 in between 0 and 3. Substitute into the function. I get positive, 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 negative. So once again, it's going to be negative. And next one, I'm going to choose x equals -1 in this interval. Substitute into the function. I will get negative, positive, positive, and negative. So we have 2 negative signs. So now our outcome will be positive. So the last interval, I'm going to choose x equals negative 10. And we're going to have a negative. After we have the positive and negative signs, we have to go back to our inequality to look for our solutions. We want our function to be smaller or equal to 0. This means, first, we need to include all the zeros, as there is an equal sign on the inequality. Second, we want to have all the negative region. Then, we can make our conclusion. X is in between negative infinity to negative 2, union, square bracket on 0, all the way up to 6 and square bracket. There is another efficient way to determine the positive or negative signs for each interval divided by the zeros on the number line by using the leading coefficient of the expanded form and the order of the roots, which is also called the zeros. The leading coefficient can be easily found by expanding the first terms of each factor, and the order of the roots is determined by the exponent associated with that particular factor. Let's construct the number line again for question 9 and 10 to illustrate this method. For example 9, first let's find the leading term. The leading term can be found by multiplying all the first term with exponent of each factor. So we will do x squared times by x times by negative x, which is going to be negative x to the power 4. Then we're going to construct the number line again and put the zeros on. Since the leading term has a negative 1 as a leading coefficient, and if the leading coefficient is negative, that means on the most right-hand side interval is going to be negative. Next, from the most right-hand side interval to go to the next interval on the left, we have to go through the root 8. And root 8 is coming out from this bracket, and the exponent is an invisible 1. If the exponent is odd, that means we have to switch the sign. So negative will be switched to positive. Next, we have to go from this interval to go to the next interval on the left. We have to go through the root number 4. And this root was coming from the first factor here with exponent of 2. If the exponent's even, that means the sign doesn't change. So the positive sign will remain the same for the next interval. Next, we have to go through the root negative 5 to go to the next interval on the left. Negative 5 was coming from the second bracket here, and there is an invisible exponent 1. So since the exponent is odd, that means we have to switch the positive negative sign. So now we are going to have a negative. As you can see, we can determine the positive and negative signs of each interval without substituting the x values into the function to calculate it. And at those 3 roots, we say 4 has an order of 2 because exponent is 2, and negative 5 has an order of 1 because exponent is 1, and at 8, the order is 1 because the exponent is 1. Finally, all we have to do is check the inequality and make sure that we do not include the roots or include the roots based on the equal sign on the inequality, and look for the positive and negative regions. Then we can make our conclusion. For example 10, once again, we have to find the leading term first. So we do x times by x squared times by x cubed times by x. Now we get positive 1 x to the power 7. Next, let's construct the number line with all the zeros on. Since our leading coefficient is a positive 1, it's positive. That means our most right-hand side interval will be positive. Now, let's go through the root 6 to go to the next interval on the left. 6 is coming from the last bracket here. The exponent is 1. So we know the order of the root is 1. It's odd. So we switch the positive sign into a negative. Next, we have to go through the root 3 to go to the next interval on the left. 3 is coming from this bracket here with the exponent of 2. So we say the order of the root is 2. It's even. So we keep the same sign. Next, we have to go through the root 0 to go to the next interval on the left. 0 is coming from the x with the exponent of 1. So we know the order of the root is 1. It's odd. So we switch the sign. So positive. Next, we have to go through the root -2. -2 is coming from this bracket here with the exponent of 3, which is odd. So we know the order of the root is 3. So we have to switch the sign to a negative. Finally, we just need to go back to the inequality to check whether or not we have to include the zeros if there is an equal sign, and look at the positive negative region because less than 0, so we want negative. And then we can make our conclusion. On a final note, the degree of the function plays an important role as well. If the degree of the function is even, that means on the ends of the number line, they need to have the same positive or negative sign. If the degree of the function is odd, then on the two ends of the number line, they need to have opposite sign. This is a very good way for us to check quickly whether or not we have calculated correctly.